So this is section 12.2, exponential, finding linear and exponential functions. So we have four tables and we're trying to determine which ones are exponential, which ones are linear. Also, could we come up with the equation for each one of these particular tables? So let's go back to the drawing board. Let's go ahead and write out the table. So I'm going to make a table here. And this is x and f of x. And then we start 0 to 4. So zip 1, 2, 3, 4. Oops. Okay. And so we have 16 for 0, huh? So 16, 8, 4, 2, and 1. So we can see here that it's 16 divided by 2 to get the 8, and then the 8 divided by the 2 to give you 4, and the 4 divided by 2 to give you 2, and 2 divided by 2 is 1. So we can see that the a factor is a half. And we also see that here's where it starts, the initial. So I know my c is 16. So if we have f of x equal to c times a to the x, it looks like it's going to be 16 times 1/2 to the x power. Now, you can do another step. You don't necessarily have to evaluate this way. You could just pick 2 points, these 2 points, to calculate your equation. So if I have f of x equal to c times a to the x, I'm going to pick my first point. I'm going to put 16 here and a to the 0. And I know anything to the 0 is 1. So c times 1. So then I know that c is 16. Okay, now that I know that, I can put that into my equation. And so now I can pick another point, the 1 comma 8. So 8 here, 16 here, and then 1 here. And a to the 1 is just a. So now I divide by 16. I get a half. And so now I know my equation just like I have over here. So if you can't see it in the table, you can just pick 2 points. And I would pick the 2 points that are 0 and 1 if possible. If that's what they give you, because that just makes it easier. We could do a different one if we wanted to. Like, for example, I definitely want to get 0, 16, but I could have picked the 3 comma 2. So that would have been 2 equal to 16 a to the third. Okay, so then I would have to divide by 16 here. So then I get 1/8 a to the third. And then to get rid of this, I would take this to the 1/3 power. And so 1/3 of 1/8 is actually a half. And so I can still do it, just that I think it's nicer and easier to pick this 2 smallest x values that they give you to make it easier to solve. So it's your choice. So now if we take a look at another table, okay, and let's say again it's 0 to 4, so 1, 2, 3, 4, and the values for the y is 5, 7, 9, 11, and 12. No, 13, sorry. And I can see the difference between all of these is just changing by an increase of 2. And so again, it would be easy to see that this is not exponential because it's just an increase of 2. It's linear, so it's going to follow this pattern. So the mx plus b, and so these are all 1s all along here. So this means that my slope is going to be 2 over 1, or just 2x, and I know my y-intercept is 5. So I've just found my linear equation, and that's basically how that setup works. So that's how we did it before. Again, if we are looking at another table and we want to know if it's exponential or not, okay, again we'll go to 0 to 1, 2, 3, 4, and then we go, let's say it's 1, 3, 9, 27, and 81. We can see here that it's multiplying by 3. So 1 multiplied by 3 gives me 3. 3 multiplied by 3 gives me the 9. 3 multiplied, 9 multiplied by 3 is 27, and 27 times 3 is 81. So this tells me it's exponential. It's not linear because it would be just an increase or decrease by the same number. And here we're multiplying everything by 3. So that tells me right away that the A is 3. And then I know my C has to be the one with 0 in it, so there's 1. So if I finish writing my equation of 1 times 3 to the x, or we could just write it as 3 to the x because the 1 doesn't do anything. So we could prove that again doing it the other method where we have f of x equal to c times a to the x. We just pick the first point. So that's 1 equal to c times a to the 0. A to the 0 is 1. So c is 1. So now I have f of x equal to 1 times a to the x. I pick another point. So that would be 3 equal to 1 times a to the 1. And so 3 equals a. And so now I have the same equation as I did before. That would just be 3 to the x. And so this is just two different ways of doing it. Either looking at the table and seeing the pattern, or just plugging it into the equation to build the equation in the end.